Greetings, friends of chemistry. Okay.
So,
So Martin and I are doing On Your Own 13.8. Martin, will you read it for us, please?
suppose you perform two experiments. In the first, you run a reaction that we will call reaction A. This reaction is very hard to start, but once it gets started, it gets very, very hot. In the second experiment, you run reaction B. This reaction is incredibly easy to start, but it only gets slightly warmer than before you began the experiment. Draw an energy diagram for each reaction based solely on what I have just told you. Note that since I gave you no numbers, your vertical axis should not be labeled with numbers.
So we're going to draw an energy diagram. If we look on pages 436 and 438, we see two energy diagrams. One is an endothermic reaction, the other is an exothermic reaction, right? In which the energy state of the reactants is lower than the energy state of the product. That will be an exothermic reaction. And an endothermic reaction is where the reactants are at a lower energy state than the products. The products are at a higher energy state. So in addition, when we look at the diagrams, we see several parts. Okay, so I want to draw. How do we determine the activation energy in this diagram, Martin? Where would you find the activation energy?
At the top.
It's this here.
The
difference between this and this is the activation energy, right?
Yeah.
Now, if it's an exothermic reaction, look, the reactants energy level will be lower than the product energy level, right? This is an exothermic reaction. If it's endothermic, we'll have something different. Whoops. Right? Look.
Yes.
The products and the reactants will be at a higher energy level than the products. And here is the activation energy, right? So thinking about what we are asked to describe in reaction A. In reaction A, we're not told any values. So we just draw a graph, okay? So it's very hard to start. What does that mean?
It means it takes a lot
this
of
is going to be
activation
big.
Energy.
And it gets very, very hot. That means that the difference between this and this is going to be big as well,
yeah.
Right? So let's go like this. A big, and then a big. How's that look?
Isn't it supposed to be hot?
Very hot. Look how different it is. A lot of energy change.
Yeah, it's got less
let's look
energy
at B.
now, but it's got less energy at the end.
It's an exothermic reaction. An endothermic reaction. This is an endo. This is an exo. Because so it's being released as heat.
If it's hot, then it goes lower.
That means that heat is a product.
All right.
Right? But if you look at the examples, Martin. Right? Those are exothermic examples. Okay, how about B? B is very easy to start. So look, this is going to be small.
Yes.
And the difference in temperature, it's only slightly warm. Okay? So this and this aren't going to be that different, right?
Yeah.
So how does that look? It's lots smaller here, and it's much less different. Okay?
All right.
So that would be something that you could draw for B. As long as your B looks plausible, I can't mark it wrong, right? As long as your B has a much lower activation energy and a much smaller difference between the products and the reactants energy level
Then A.
than A, which is hard, difficult activation energy, big bump here, and a dramatic difference between the products and the reactants
Okay.
temperature level. Okay? So that's it for 13.8. There's nothing else. Is that correct?
Indeed.
Excellent. We're going to stop here and come back for 13.9.